Hey, we all
have to
play.
qualify.
Alright, so I know it's been a little while since we did some examples. If you remember or look back to the previous examples, 3, 4, and 5, we were using problems that were similar to 1 over 1 minus x, but each of them had something a little bit different about them, and we were creating the series for those. Today, example 6 and 7, we're going to continue. They're going to be similar to those ones that we were doing last week, or I guess it would be the beginning of this week. And then when we move on to examples 8 and 9, something's going to change a little bit with them. So let's go ahead and continue the ones that are similar to the ones last week. Alright, so it says at the top, when you replace x with a multiple of x, beware a change in the radius and interval of convergence. Okay, so example 6. Find the power series that represents 1 over 1 minus 2x, centered at c equals 0. So that's what we were dealing with last week. Everything was centered at 0. Find the interval of convergence, include the first 4 non-zero terms and the general term. So again, what's changed? We have 1 over 1 minus x is that one we had memorized. I guess to think back, since it's been a while since we've done that, let's write the 1 over 1 minus x again just as a refresher. Does anybody remember what the 1 over 1 minus x power series was?
Isn't it just like 1 plus x squared plus...
Yeah. Okay, so that's the 1 over 1 minus x. This problem that we're dealing with, 1 over minus 2x. So what we have to do is substitute 2x into 1 over 1 minus x. So 1 over 1 minus 2x is equal to
1 plus 2x
Yeah.
plus 4x squared plus 8x cubed.
exactly. So everywhere there's an x, you plug in 2x. So 2x to the nth power. Not too bad. But now we have to go back. We used what test to check for these? What test did we use to find our interval? Ratio test, yes. So limit n goes to infinity. Absolute value. Well, on the top is the n plus 1 term, so we have 2x to the n plus 1 divided by 2x to the n. Simplifying that, we're left with the absolute value of 2x. We want that to be less than 1. So we can divide that 2 and get the absolute value of x less than 1/2. So we're centered at 0. So the radius is this 1/2. So we can go 1/2 to the left, 1/2 to the right. So we know our interval is going to be from negative 1/2 to positive 1/2, but we don't know yet if we need parentheses or brackets. So we have to test the endpoints. Summation n equals 0 to infinity of negative 1 to the n. And that diverges. And then the summation of n equals 0 to infinity of 1 to the n, that also diverges. So parentheses or brackets. Yep. So all we did was test our endpoints in this term here. So the 2 times the negative 1/2 became negative 1, and the 2 times 1/2 became 1. That's why this is negative 1 and positive 1. So again, that's our final interval right there, negative 1/2 to 1/2. And we have the first 4 non-zero terms and the general term, so we have answered everything they have asked for. Okay, again, very similar to the examples we were doing last time. All right, example 7. It's going to be a minor difference here. So find the power series for g of x equals 1 over 4 plus x, centered at c equals 0. Then find the interval of convergence and include the first 4 non-zero terms and the general term. So this problem is a little different. We haven't done one like this yet. We did an example where we multiplied by the x. That was the example up above. We did a problem where we had a value on the top that was different, because that's our first term. Think about geometric series, first term over 1 minus the ratio. But we haven't done anything where we had this value here changing on the bottom. So what we're going to have to do, even though our center is still at 0, we're going to have to kind of redo our series or make our series again. So one way we had found at the beginning of this section to find the series was long division. So that's what we're going to use for this problem, because this is telling you do 1 divided by 4 plus x. So we're actually going to go through that long division to find our new power series. So 1 divided by 4 plus x. So what do we have to multiply 4 by to get 1? So you need to think about that. Caitlin? 1/4. So that's the first term. And I multiply these both by 1/4. That gives me 1 plus 1/4 x. And I need to subtract those. When I subtract those, the 1's go away and I'm left with negative 1/4 x. So now, what do I have to multiply 4 by to get negative 1/4 x? It's going to be a negative number, so I need a minus there, 1/4 minus. So what do I multiply 4 by to get 1/4 x? 1/16 x. Yep, negative 1/16 x. Okay, when I multiply that, I would get the negative 1/4 x minus 1/16 x squared. When I subtract those, again, those terms are going to cancel. Left with 1 over 16 x squared. And let's go one more term. So what do I have to multiply 4 by to get 1 over 16 x squared? It's going to be a positive. Yep. 1 over 64 x squared. Okay. No, that's kind of a mess there. It's hard to read, but 1 over 64 x squared. That's all the further we're going to go right now. So maybe we can figure out the pattern. So let's write it out. 1 over 4, that's the first term, minus 1/16 x plus 1 over 64 x squared minus, it's alternating, what do we think the next term is going to be? We're going to have x cubed. What is the value in front? What do you think that's going to be? Yeah, 1 over 256. So that's the first 4 terms. So how did Eric find that? 1 over 256. I mean, that may be true. You're welcome. So if you think about the denominator part, this is just 4 to the first, 4 to the second, 4 to the third, 4 to the fourth. So it's going to continue on in that pattern if you think about the denominator. So I'm going to write it down below, but we need our general term. So it is alternating, so we have negative 1 to the nth. What else do we need on top? Yeah, x to the nth. And this bottom part is what we just talked about. We know it's dealing with 4. What's our exponent, though? Let's see.
Okay.
The first term is going to be starting at 0, so if I plug in 0, I'd get 1.
Okay, that's n plus 1.
So yes, it's n plus 1.
And why does the person have to start with 0?
I think in this case, let's see here, because you want the x to go away. You don't have an x term, so x to the first power would have left an x there. X to the 0 power gets rid of the x, makes it a 1. That way you don't have an x in your first term.
Why couldn't it be x to the n minus 1 over?
You could change this to n minus 1, and that could have been n. You could have done it that way. Mathematically, it would have been the same thing. But we just chose this as x to the n because we had 0 here, wasn't there, x to the first power, x to the second. So that's just how we've been making the patterns, but you could have done it that way.
Okay. And it wouldn't change the outcome?
No. All right, so that is our for and our general term. So now we have to do our ratio test again to find our interval of convergence. Limit, as n goes to infinity, absolute value. Again, we don't need the alternator. We just have to do the n plus 1 term over the original. So x to the n plus 1 over 4 to the n plus 2. Now again, dividing by the original, multiplied by the reciprocal. 4 to the n plus 1 over x to the n. After some reducing, you're left with the absolute value of what? If you reduce all those powers, you're left with what? Yes, x over 4. And again, with the ratio test, we want that to be less than 1. So next, we can get x by itself, multiply by that 4. Absolute value of x less than 4. So again, we can see this time that changed. Our radius is now 4. Our center is the same, but when we changed this to 1 over 4 plus x, that changed our radius of convergence. So the radius is now 4 to the left and 4 to the right from 0. So negative 4 to 4. But we need to check our endpoints. Since I ran out of some room, I'm going to erase this here so I have some room. So checking the endpoints, summation n equals 0 to infinity. Again, we're plugging it into the general term. Negative 1 to the nth. Negative 4 to the nth over 4 to the n plus 1. And for this one, we get diverges. The bottom is going to grow faster. Let's see. Actually, it goes to 1/4, sorry. So yeah, diverges. Let's see. Do you agree with that? Diverging on that one? Yep. And then if we look at the next one, it's the same thing but plugging in positive 4 for n, so it will also diverge. So our interval, negative 4 to 4. Yeah, Eric.
So, is there a way, so, I mean, like in the previous problems where we just like plugged in, like the one before we just plugged in 2x, 2 power series, could I manipulate g of x by, say, pulling out a quarter as like a coefficient for the whole thing, saying you have a quarter of 1 over 1 then I would just plug in like a negative 4x
So are you saying could we have gotten this without doing this over here? Is that-
without the long division, yeah.
So now that we've gone through it, you know a pattern to it. So yeah, you could use that. Since it has the 1 over and there's a plus x here, when we had the plus x, that's when we had the alternating. So you would have, now that we've gone through examples, you know that's alternating, so you would need alternating. And now that we've done an example with that 4 there, you know what that does to it. So yes, now you know the patterns, so you can do that. But we didn't know what the pattern, we didn't know what it was going to do until we did this first example. Now you know how it manipulates it. So yes, if you have that idea and remember it, and you're on a test, you can use that idea to find that if you remember the pattern. But if you don't remember the pattern, this is how you would do it, going back through the long division.
But
Yep.
even if I didn't like want to memorize the pattern, could I just manipulate g of x such that I could just plug in things for x and then multiply everything by a coefficient? Would that still work?
What exactly do you mean? I'm not sure if I'm following.
So I took we had the 1 over 4 plus x, and then I took out the 4 out of the bottom, so you had 1 plus 1/4 x, right? And then you had a 1/4 coefficient for the whole thing. And then I just took, you can multiply everything by 1/4, and then I plugged in negative 1/4 x for everything.
Do you have written down what you're talking about, or no?
I don't know.
Because I'm still haven't. Could you write it down? Maybe
Is it
what?
on the board or something?
Yeah, go ahead. Over there, or whatever.
So I just took a 4 out of the bottom. So you had So then the difference here is you have the negative 1/4 x, which is you would plug in for your x value and your 1 over plus x, right? Or 1 minus x. And then I would multiply each term after I plug this in. I would multiply every term by this, so that's still.
Like you're thinking, man.
Would that still? I guess my question is, would that still work mathematically with the ratio?
Let's see. Oh, what was that example at? Alright, so this example we have here, example 6 that we just did. When we had something in front, you multiply by, so you multiply by that 1/4 everywhere. Okay. If it was plus, you're going to have alternating. Okay, so that's
So you
going
have
to
the alternator because when you just plug this in, your x squared, so then cancel that. And you get the alternator when you plug it in.
I think that would work. So yeah, that's another way to think about it. But yeah, I think that would be another way to do that. All right. So are we good now, Eric? We're good? Okay. All right. Anybody else have any questions on example 7? All right, let's take a look at 8 then. We have some time left. So example 8, we're going to change up a little bit here. Sometimes we cannot center our function at x equals 0. In this case, we must try to rewrite our function with a new center. So example 8, we're going to find the power series for 1 over x. Again, we can't center that at 0 because if we plug in 0, it's undefined. So we're going to move our center to c equals 1. Then find the interval of convergence, include the first 4 non-zero terms and the general term. So again, since our center's changed and we have this new series 1 over x, let's go back to the traditional way that we actually had found the series last section, which again was listing derivatives. So I'm going to start out with f of x equals 1 over x. How many derivatives do I need to take? I need to go to which one? If I want the first 4 non-zero terms. I need 3 derivatives. Derivative of 1 over x. What is that? That would be the integral. Derivative. Yep, negative x to the negative 2, and we'll leave it like that because it'll be easier to take the second derivative. 2x to the negative third, and then the third derivative would be negative 6x to the negative fourth. Does anybody remember what we did after we had taken the derivatives?
Plug in C.
Yep. Plug in C. So we're going to get a value for each one of these. Again, these values are coefficients. We get 1, we get negative 1, we get 2, and negative 6. Again, those are the coefficients of our first 4 non-zero terms. So just like we did in the last section, we had list out our series. First term is 1. That's f of x. It would be plus, but our coefficient's negative, so we're going to have minus. The coefficient's 1, but the coefficient of what? What is that multiplied by?
X minus 1.
X minus 1. Yep. Then I have plus 2, and 2 is the coefficient of what?
X minus 1 squared. Over 2.
Yeah, x minus 1 squared, don't forget, it's over 2. Which I know those cancel, but we're keeping the pattern right now, so. Then we would have minus 6 to the x minus 1 cubed over what?
6.
Or, yeah, 3 factorial. Or 6, so they would cancel. Plus dot dot dot. So really, what is the general term? How do you find the general term for this one?
Just x minus c, or x minus 1 to n plus 1.
It would be, well, we have x minus 1 to the nth. Do we need to worry about coefficients at all? They cancel out. What about the positive and negative?
Negative 1 to n.
So negative 1 to the nth times x minus 1 to the n. Again, your coefficient's going to cancel out with the bottom, so we don't actually have to worry about the factorial. So that's how the power series of the 1 over x looks. Alright, so now we found the first 4 non-zero terms and the general term. Last thing is interval of convergence. So once again, ratio test. Limit. It is absolute value, so don't worry about the alternator. X minus 1 to the n plus 1 over x minus 1 to the n. Since you have n plus 1 and n on the bottom, that just simplifies to absolute value of x minus 1. We want that to be less than 1. So in this case, do I need to add the 1 to the other side? Need to be careful with this one. Do I need to add 1 to the other side? Shaking your head, Caitlin. Why not?
Because that's where it's centered at, so you want that to be like included in like.
Exactly. Yeah. If we look at all of the other problems we had done, if you look back, we always got the absolute value of x less than some value. Well, our center was at 0. There was nothing attached to our x. Our center is now 1, so that minus 1 is always with the x there, because that's where our center is. We're trying to find the radius that's around our center. Our center is at x minus 1, so this radius of 1 is from our center. So if you think about our center being at 1, our radius is 1, our interval is going to go from where to where? 0 to 2. So we need to check those. This time, I'm not going to write them out. Let's just think about it. So if we have, if we plug in the summation n equals 0 to infinity, we have negative 1 to the n, because if you plug in 0. Negative 1 to the n diverges. If you plug in 2, 2 minus 1, that gives you 1. 1 to the n also diverges. So both endpoints are going to diverge. So your interval is 0, 2. That's your interval of convergence. Again, we were centered at 1, so the radius is 1 to the left, 1 to the right, 0 to 2. All right, go ahead and flip over. All right, so this one here has a lot going on with it. Find the power series of h of x for 15 over 2x minus 1, centered at c equals 1. Find the interval of convergence, include the first 4 non-zero terms in a general term. So this one's a little trickier, a little more to it, but again, we're going to go through the same process we just did with the previous example. What we learned about the Taylor series, you need to list your original, list your derivative, second derivative, third derivative. So I'm going to give you some time since we have some time left. Go ahead and try this one on your own, at least start it. If you want to work with somebody beside you or make a small group, you can. But start working through your derivatives on this one and set up your Taylor series. See if you can get to finding the general term, and we'll check and see if you get the right answer. So I'll give you some time to work through that. When you get to the option of making your general form, go ahead and reduce your fraction, your factorials. They will reduce with the coefficients on the top. That's what I have for the derivatives and evaluating the derivatives, if you want to check that part of it. Then go from there. Any questions about the derivative parts? We're okay with those? Good, Eric?
Oh, okay. I just did it the other way I was talking about the other way.
Okay.
I was thinking but I just wondering if it's gonna work out when you actually look at the problem.
Okay, we'll have to see then. So you went about trying it that way?
Yeah, and
Okay.
I have similar numbers, but all those coefficients over 4.
And what might make a difference on this one too is we have a number on the top too. It's not just one. So like, there's a lot going on this one to try it,
Yeah.
but we can see if it works out. Anybody find general term yet, or we're still working on that?
It's visually much more.
Wait a minute. I see one major mistake. Where's your center? Yeah, so you can't just say, you can't just use 1 over 1 minus x. Because your center is different.
I can only use that.
Only if the center is the same, so that's why, yes. So your reasoning, you have to use that only if the center is the same. Because you know the pattern is when the center is 0. You don't know the pattern yet when the center is not 0. Make sense?
Yeah.
Okay. Where's everybody else at on the problem right now?
Just trying to general.
So you've listed out your terms, you're working on general term though, same area? Okay. So is this what you had gotten for your terms at least when you started listing them out? Remembering your center's at 1, so you have to have x minus 1 with all those. You can reduce those coefficients. Do you see the general term yet, what it might be? Anybody try it yet?
There's definitely an alternator.
Yeah, we have the alternator. We know we're going to have an alternator. We know we're going to have x minus 1 to the n power. Those two we can know for sure. We start out with 15. You know your first term's 15, so you have to have a 15 in there. But then, every time 15 is multiplied by some value, well, after you reduce that, you can see it's 2 to the n that it's being multiplied by. So when you plug in 1, it's just 15 times 2. When you plug in 2 squared, you get 4, so 4 times 15, that's where the 60 comes from, and so on.
Yeah, it's just that 15 times
So-
2.
yeah.
And that was the part that I couldn't
Okay.
really-
So we're going to go through the rest of the problem on Tuesday. We'll finish it Tuesday. Because we didn't do the interval or anything yet, so we'll check that. But that's it for today. Class is about over. You got about a minute left. So if you have some time and you want to